The hot chocolate effect, also known as the Alasonic effect, is a phenomenon of wave mechanics. It was first documented in 1982 by Frank Crawford. In simple terms, it's where the pitch heard from tapping a cup of hot liquid rises after the addition of a soluble powder. It can be observed by adding salt to supersaturated hot water. However, it also occurs in more everyday activities, such as making a warm cup of hot chocolate. So the next time you're making some hot chocolate, purely for scientific purposes of course, as you stir in your cocoa powder using a metal spoon, listen to the clinking noise it makes. Notice that the pitch drops, then stop stirring, but keep tapping the outside of the cup. Notice that the pitch rises again. The phenomenon can be explained by the effect of bubble density on the speed of sound in the liquid. The note heard is the frequency of a standing wave, where a quarter wavelength is the distance between the base of the mug and the liquid's surface. Because frequency equals speed over wavelength, this frequency is equal to the speed of the wave divided by 4 times the height of the column. The speed of sound in a liquid or gas is dependent on the fluid's mass density and the bulk modulus. The bulk modulus of a substance measures the substance's resistance to compression. Water is approximately 800 times denser than air, and air is approximately 15,000 times more compressible than water. When water is filled with air bubbles, however, the fluid's density is very close to the density of water, but the compressibility will be the compressibility of air. This greatly reduces the speed of sound in the liquid. Seeing as wavelength is a constant for a given volume of fluid, the frequency of the sound will decrease as long as gas bubbles are present. There are more gas bubbles in the liquid when the powder is added because the air clings to different grains, and also the process of mixing the powder in will mix in some air with it. As more powder dissolves into the water, the air bubbles float to the top and pop, rejoining the air. As fewer and fewer bubbles are in the liquid, the speed of sound through the liquid increases. The frequency also increases, and therefore the pitch gets higher. Thanks for watching!